Today we discuss week 4 solution for question R given in the machine learning assignment with answer. So first let's discuss from the question 2. How does the set of hypotheses look like after having handled the following three instances? Instance 1, angry black horse, happy brown cow, that is a positive. Then instance 2 is angry brown cow, happy black horse, positive. Instance 3 is angry brown horse, happy brown horse, it is negative. So question 2 is using a depth first search, what is a CBH3? So these are the options. Now for answer, first we respond, that is this is CBH1, that is the same as it is angry black horse, happy brown cow. So angry black horse, happy brown cow, that is the CBH1. Now for CBH2, we move to the hypothesis that angry is same. Now move to the black or horse, which is matching or not. So if not matching, then question mark. So angry, then question mark, question mark. Similarly here happy, question mark and question mark. For CBH3, now move to the second part. Angry is completed and here happy is completed. So generalized hypothesis, first question mark, then black horse, and here question mark brown cow. So that is the correct answer for the question 2. Now move to the question 3, that using a breadth first search. So these are the options given in the assignment. Now for answer, S1 is the same as it is instance 1, that is the same, angry black horse, happy brown cow. Then for S2, here now using breadth first search. So first we have to go with the second row, that is the question mark generalized from black horse, question mark brown cow, and second thing is angry, question mark, happy, question mark, question mark. So that is the S3 whatever there in the CBH2 and CBH3, that is combined here in the using breadth first search. Now S3, now for S3 we have to move from this particular first part, that is the third row, that is a black horse and brown cow, then S4 is there. But here as using S3 using breadth first search, we have to find only S3. So S3 is question mark black horse, brown, question mark brown is the correct answer. Now question 4 is using the version space approach. So these are the options. Here actually cat is there, but correct one is a cow, not cat. Answer. So S1 as it is. Now for G1, that is hypothesis, we don't know, so we start with the question mark for two sequences. Now S2, so we start with the whatever we have derived in the breadth first search. So first black horse, then brown cow, and angry, question mark, happy, question mark, question mark. Now G2, we don't know this upper one answer, so we continue with the question marks for the two sequences. Now S3 same as the earlier one, but here G3 is that. So first is question mark, then black. We find the first part. Black is whether it is matching or not. Then we consider hypothesis third one, is a question mark. And for that particular black, whether it is same matching or not, so that we generalize as a question mark, question mark, question mark. Now here for the second part from the brown and cow, so here black is there. So now move to the second part in the second sequence. So third part in the second sequence, so question mark, cow. And here again we don't know the hypothesis, so question mark, question mark, question mark. So this is the correct answer for S3 and G3. Yes, this is a it must be cow in place of cat in the question for all the option G3 as well as option answer in G3. So now question 5th, what is the entropy for decision tree data set with 8 positive and 2 negative example? So this is a simple formula based answer is there. So P plus is the proportion for the positive example, P minus the proportion for the negative example. 8 positive example, 2 negative examples, so total example is 8 plus 2, 10. So here calculate P plus 8 by 10, 0.8, P minus 2 by 10, 0.8. So HS is equal to minus 0.8, logarithmic base 2.8 minus 0.2, logarithmic base 2.2. Approximation of the logarithm log 2 and log base 2.8 is value minus 0.3219. Log base 2.2 is minus 233 minus 3.3221. So that is the calculation. In simple case, you can calculate log base 2.8 is log 10, log base 10.8 divided by log base 10 2. So that is the same as whatever we have calculated here, and then finally put your all the value in the given equation and you get the answer. That is about approximately 0.72. Now question 6, what is the value of the information in the following partitioning. So the entropy n is and 400 entropy 0.8 and 70 entropy 0.6 and 30 entropy 0.4. So to compute the information gain for the given partition, we use the formula IGHS minus sigma in bracket sigma SI divided by modulo of SI in multiplication of H into SI. So HS is the entropy for the parent node, SI is the child node, and mod SI by SI is the proportion for the sample in each child node. So first parent node is 100, entropy H of S is equal to 0.8, then left child node entropy and 70 entropy H of S was 0.6, right child node and 30 entropy H is to 0.4. So step 1, compute the weighted entropy for child node. So just put this value SI by S, so 70 by 100 into 0.6 plus 30 by 100 into 0.4. So you can get 0.54. Now step 2, compute the information gain. So this is the equation HS. So HS is 0.8. So 0.8 minus 0.54, that is equal to 0.26. So correct answer is 0.26. Now question 7, the circle represents the instance of the algorithm for value k, 1, 5, 9, 11. This is a query instance classified as blue, instance classified as red. So for first one is a blue is there, second one 2 blue, 2 red, for third 3 blue, 3 red, 1 blue, for fourth one there is a k equal to 11. 2 red is there. So for which value of the k is equal to blue by the k nearest neighbor will answer. So answer blue 1 and 1 green. So for k equal to 1, blue 2, red 2 for k equal to 5, blue 1, red 3, k equal to 9, and blue is not the red 3, k equal to 1. So here blue is there for first and 1 and 5. So correct option is for k 1 equal to 5. Now question 8 is about for the two feature vectors 1 1 1 0 0 0 1 and 0 0 0 1 1 1 1 1 1. What is the one-bounded distance between the two vectors? So one-bounded distance, also called the L1 distance or taxi cab distance between two vectors, and is calculated as sigma mod AI divided by AI minus BA. So this is the two sequences. Let's compute the absolute difference for each of the features. So 1 minus 0 1 1 1 1 minus 0 1 1 minus 1 0 0 minus 1 1 0 minus 1 1 0 minus 1 1 1 minus 1 0. Now sum of all these things. So 1 1 1 1 1. So that is equal to 5. Now question 9. Consider the following two vector x equal to 3 3 0 3 0 0 0, y equal to 3 0 3 3 0 0 0. Now what is the cosine similarity between x and y? So cosine between two vector x and y given by the formula x dot y divided by magnitude x multiply y. So xy is the dot product vector of x and y, and mod x mod y are the Euclidean norms magnitude of x and y. So compute the dot product. So 3 into 0, and that is where you can find the dot product is equal to 18. Now compute the magnitude of each vector. So all the square under root is there. So it is square root of each value. So 3 square plus 3 square 0 square 3 square 0 square, right, 1 by 2. So 0.5. Similarly for y, and then after you have to find value in the equation. So cosine of 18 divided by 27 3999 all 0. So 27 raised to 0.5 into 27 raised to 0.5. So that is equivalent to around 0.667. Now question 10. Consider the two-dimensional non-limited separable input space. The following feature mapping into a linearly separable three-dimensional space f x x1 x2 x1 comma x2 square root x1 x2, and z is a z1 z2 z1 square z2 square root of z1 z2. K xz, the kernel similarity function in the three-dimensional space, the inner product of x in the space. So calculate k of xz, the inner product of xz for the two-dimensional 1 2 and 2 in the input space. For kxz, the kernel product similarity, the three-dimensional space given by the particular equation x1 square comma x2 square comma square root of x1 x2 comma in second bracket z1 square z2 square root of z1 z2. And now you just compute it, then you can find the final answer x1 z1 plus x2 z2 square. So here x1 x2 is 1 2, z1 z2 is 2 1. So you get the 1 into 2 plus 2 into 1, and square that is equal to 2 plus 2 raised to 2, that is equal to 60. So now I question, what is the proximity matrix between the two cluster A, B, C, D, E, F for the given distance matrix? So this is A, B, C, D, E, F is given here. A, B, C, D is given answer. So given matrix represents the distance between point A, B, C, D, E, F. We need to compute the proximity between three clusters. So cluster 1 is A, B, second is C, D, and third is E, F. So step 1, compute the intercluster distance. So the distance between two clusters can be computed using different linkage method, such as single linkage like minimum distance, complete linkage, maximum or average linkage, that is mean distance. So we have just try with the minimum and as well as average. So first we calculate example with the help of average linkage distance. So this compute a distance between AB and CD. So DAB to DA to C plus DA to D plus B to C B to D divided by 4 parameter is there. So here A to C is 5, A to this is A to C, that is a 5. Then A to D is equal to 3. Similarly, put all the value 3 plus 3, 5, divided by 4, 16 divided by 4, 4. Similarly, compute D, AB, comma EF, and you find all this value, and compute D, CD, comma EF. CD, comma EF is D, C to E, D, C to F, then D to E, and D to F. So, like D, C to E. C to here, you can say C to E. That is the 2. C2 is 2. So, here 2 is there. So similarly, you put all the value, you get this 3 value 4, 8 and 3. So from the proximity to this, the diagonal vector is 0, 0, 0 and put AB to CD. AB to CD is 4, then AB to EF. AB to EF is 8. Similarly, EF to AB is F and CD to EF. So CD to EF is 3, and that is why 048 403 830. Now similarly, we can calculate with the help of minimum linkage distance with the help of a minimum value of shortest distance. So here determine proximity with A, B, C, D, F. We need to calculate distance between the 3 clusters based on given distance matrix. There are several methods to calculate distance between clusters, such as single linkage, complete linkage, and average linkage. For simplicity, let us use single linkage method, which defines the distance between two clusters as the shortest distance between any single pair of the point of the cluster. So cluster 1 AB, CD, and EF. Then distance between A to C, find A to D, B to C, B to D, and you can get here minimum value. So 5, 3, 3, 5. So here minimum value is 3. Similarly, calculate the distance between AB and EF. So similarly, you find here from the 7997 minimum is 7, and calculate the distance between CD and EF. So find distance between all these parameters C to F, C to F, C D to E, D to F, and you get minimum distances too. So according to minimum, this is the A, B, C, D, and E, F proximity matrix. So from the given option, I think this option is not there. So you have to select this one option. Let's see the machine learning assignment solution. So this is the 4 assignment. So first one question: the different data driven search approach integrates different storage topology. What is the version space approach algorithm to solve? This is the all hypothesis. Then this is we already discussed. Second, third, fourth, here not cat but cow. Entropy 0.722. This is 0.26. This is K1 and 5. This is 5. This is 0.67. This is 16. This is density based clustering. 12th. So this is this one. So that's it from this particular solution. Thank you.